This is a completely 3D printed 4x4 crawler, but the real question is how does it actually perform in the real world? This is a 4x4 UGV designed to carry a UAV on its back. The idea was simple: transport a drone safely or eventually launch it from a controlled location. It has front and rear steerings, which gives it a small turning radius. And it can also crab walk, which allows it to move sideways. Hey, I'm Gaurav here. At Mech Ninja, we design, build and test drones and robotic systems, focusing more on engineering decisions rather than final results. This isn't meant to be a toy, it's more like a system, something that can do planned missions, but can also be controlled using a regular transmitter. The launch platform is servo controlled, so it stays level. Initially I thought of enclosing it, but landing the drone back safely is a problem, so for now it's open. Now let's start the assembly. The drivetrain is fully gear driven. I kept it simple, spur gears instead of helical, just to validate the concept. I tested this RS775 DC motor and this 1000 kV device brushless motor. So you can use any one of them, but I'll be using this device motor because I can easily swap its direction using Bell Heli ESC. There's no differential in this version. This is my first 4x4 crawler and I didn't want to put every feature in one go. I could have bought shocks, but I wanted to understand how stiffness affects behavior on rough terrain. Because this doesn't use a differential, I couldn't increase the steering angle too much. So instead I added rear wheel steering to reduce the turning radius. I'm using a Pixhawk flight controller, mainly because it allows me to use Mission Planner. For video, I'm going to use the OpenHD transmission system we designed in the previous video. If you haven't checked out that video, you can click on the I button to watch it. I'll keep the wiring diagram in the description. So I haven't thought it will look this big in real time. And it looks really good. I'll be using this 4S battery and now let's power it. So it has a dual steer mode. Both the front and the rear wheel turns together. And you can also switch to crab mode. The gearbox is currently set for maximum torque and you can manually switch gear ratios depending on your use case. It also has adjustable suspensions. It has some different levels of it. Although it's kind of useless for now, so you don't have to do it. Now let's do its real testing in the field. The crawler reached the point but couldn't return. Both the telemetry and NRF lost the connection when it went behind the bushes. For the next test, I used a planned mission. So this is a planned mission and I have set approx 4 waypoints. Okay, now we'll start the mission.
Reached waypoint number 3. Mission 4WP.
Okay, so now I have taken the control of it. Okay, and I'll show you one of its smart feature. Okay, so this is the smart return to home land feature. So I'm just pressing it and you'll see it will automatically come back. Okay. So it lost connection twice for the same reason. It went behind the bush. Since we are operating on the ground and the line of sight is stuck because of the bushes, so the telemetry and NRF both lost the connection. But during the planned missions, the coordinates were already fed into the flight controller, so the mission wasn't interrupted. I did some off-roading with it and honestly this was the most fun part of it. about its technicality. The biggest advantage of this UGV over an RC car is the autonomy to do planned missions. The crab walk is one of the coolest features to have. Actually, I want to make it omnidirectional in off-roading and I can't put mechanism wheels. Rear wheel steerings are required to reduce the turning radius as it's a direct drive, not a differential one. But my future projects will definitely have a differential drive. All the gears are spur gears, which makes it little noisy, but these are easy to design and test. And you must be wondering why I haven't launched a drone from it. I could have launched this Mech 60 series drone that can be printed on a print bed of 220 by 220 mm and it can house up to a propeller of 6 inch. That part is easy, but I am working on automating both the UGV and the UAV, and that deserves its own video because of the complications. So the version 1 is finished here and you can download the files from the website, the link is in the description. And in the coming version, you'll see some more cool features. So hope you all like this project. So guys, I have started a poll on my website where you can decide what comes next on my channel. So do check it out. So if you have liked this video and found it informative, then you can like, share and subscribe to my Mech Ninja YouTube channel. So thank you guys for watching it. I'll catch you later with the next project.